We spent 2 million years refining the physical senses needed to survive and track movement in the wild. Every joint, muscle, and sensory organ evolved for high-speed coordination in unpredictable terrain. Then we stopped running. We sat down, we enclosed ourselves in stationary metal boxes and started moving at 60 miles an hour. You're in the back seat, reading a map or scrolling on your phone. You are in a safe environment. No predators, no physical exertion. Yet within 30 seconds, a cold sweat breaks out. Your stomach churns. You are suddenly, violently nauseous. Curious, slightly baffled. This is a biological contradiction. Why would an organism engineered for endurance and survival deploy a systemic physical purge when there is no danger and no physical damage? Your brain is executing an ancient defense protocol against an invisible threat, treating your own body like an active crime scene. To understand what sets off this alarm, we have to look at how your brain tracks reality. At any given moment, your eyes are streaming visual data, while your proprioceptive system, the sensors in your muscles and joints, reports your physical posture. Your spatial awareness relies on the vestibular system, fluid-filled semicircular canals acting like microscopic spirit levels. When running, your eyes, muscles, and inner ear synchronize. But in a car, staring at a phone, your eyes report zero movement, while fluid reacts to every turn. Your brain is suddenly handed two contradictory physical realities. It cannot merge the math. This conflict creates the physical symptoms we recognize as motion sickness. If motion sickness is just a mechanical error, we have to explain a massive behavioral anomaly in the. Why doesn't the person driving the car get sick while the passenger next to them does? The driver uses predictive processing. Initiating steering generates a motor command that updates the brain's spatial models before movement happens. But passengers have no predictive buffer, receiving forces passively. This forces conflicting data into a bottleneck, causing a massive system overload. We see the extreme limit of this overload when a human leaves the atmosphere and enters a zero-gravity environment. Without a gravitational baseline, the vestibular system is essentially disabled, floating in a void of meaningless data. Space agencies use massive centrifuges to test and train humans against this spatial confusion before launch. We can map exactly how the sensors disagree, but that disagreement doesn't explain why the brain responds to confusion by purging the stomach. Vomiting is a highly specific evolutionary tool. It is designed to empty your stomach of physical, ingested toxins. Under normal conditions, there is no logical reason to empty your stomach because your inner ear and your eyes disagree about acceleration. But consider the timeline. For millions of years, the human nervous system developed without engines or virtual reality. In nature, motion almost always matched. Out in the wild, there was only one scenario where your eyes told you the world was perfectly still, but your inner ear insisted the world was spinning. That was the ingestion of a neurotoxin. This is the basis of the poison hypothesis. It proposes that the brain evolved to interpret severe sensory conflict as a symptom of neurological poisoning. When the balance data corrupts, the brain assumes you ate something toxic and triggers nausea to expel the imagined poison. Your brain is applying a survival rule. It believes you have been poisoned, and it is trying to save your life. The poison hypothesis is a leading evolutionary theory, but it is not a proven biological law. Scientists continue to look for alternative explanations for why this response exists. One primary competing idea is the postural instability hypothesis. This suggests that nausea stems from the physiological stress of the brain losing physical control of its balance, rather than a false alarm about toxins. While scientists debate the ancient motive, the modern trigger is the rapid invention of unnatural transportation. Biological evolution moves slowly. We spent millions of years adapting to walking speeds, and then in barely a century, we built engines that can throw our bodies through space at incredible velocities. Motion sickness shows that we are biological machines living in an artificial world, surviving by rules written long before roads existed.